Welcome. Today we will be viewing the Unit 10 study guide for Algebra 1, focusing on our use of graphing inequalities on the coordinate plane, as well as systems of inequalities. To begin, for graphing those linear inequalities, we want to recall that we need to be trying to graph in that form of y equals mx plus b for our linear equations, focusing on that b value for the y-intercept and the m value for the slope. So when we look at the first example here, we begin with the b value. That's going to be our -2. That's at the end of our problem. So I mark -2 on my y-axis. And then we look for the m as the coefficient on x. That is our slope of 1/3. So from this given point, up 1 and to the right 3, plot that point. Up 1 and to the right 3, plot our point. Up 1 and to the right 3, plot our point. Same way we can go in the opposite direction, down 1 and left 3, we can plot. Down 1 and left 3 to plot that point. Down 1 and left 3, plot that point. Once you have these points lined up, remember then you have to determine if you are going to have a solid line versus a dashed line. Recall that you will have a solid line if you have a greater than or equal to or a less than or equal to in your inequality. If there's extra ink to draw that underline, then it's extra ink to make it a solid line on the graph. You use a dashed line if you have a greater than symbol or a less than symbol. So when there's that open space where the or equal to line could be, you're going to have open spaces in your dashed line. So comparing with that inequality symbol for number 1, I have the extra underline for that or equal to, so we make that a solid line. And then we have to do the shading with this. Right now this says y is greater than, and so that y is greater than is going to have our shading up above of the line. So we would have the shading this way. You can also consider using a test value. Perhaps you'd like the point at 0, 0. So if I use 0, 0 as a test, where x is 0 and y is 0, I'm going to compare 0 greater than or equal to 1/3 times 0 minus 2. So 0 is greater than or equal to 0 minus 2. We'll do that subtraction on the right, and you're asking yourself, is 0 greater than or equal to -2? Is 0 greater than a -2? Yes, 0 is greater than any negative number. This is true. So certainly you will shade over top of that test point, which is exactly what we've done. The shading is over top of that point. So if we go down below to our next example, comparing again with the y equals mx plus b setup, you are going to begin with the b, so my y-intercept at +1. And then working with that slope, my m value, this is at -2. So we're going to move down 2, and don't forget to the right 1 as well. Okay, that m value as a -2, thinking -2 over 1 for that fraction. Same thing again. So down 2, right 1, and down 2, right 1, down 2, right 1, and down 2, right 1. There we are. You can turn that around certainly and go the other direction, up to left 1, and up to left 1, up to left 1, and up to left 1, so that you can have these points available. Again, now we're going to have to look at the sign for any inequality. That's a less than. There is no underline with it, so this is going to be a dashed line or a dotted line when you plot that. And then thinking about our shading, here we are, y is less than. When I read y is less than, I have to think lower. And so yes, we can shade the lower side of that line. Again, if you wanted to select a test value for this, make sure that whatever test value you pick is not on the line. So you might use that 0, 0 again as another test value. If I plug that in, 0 for my y, and then 0 plug in for my x, work that out. 0 now is less than then negative 2 times 0 makes 0 plus 1. So is 0 less than 1? That's what we're asking. Yes, 0 is less than 1, so certainly you're shading the half plane that includes the 0, 0. That's fine. Just so you can see it with another value, if I had chosen a test value here, perhaps, right? What if I had done that test value as 3 comma 0? Well, my y value then is 0, less than negative 2 times the 3 plus 1. So negative 2 times 3 is negative 6 plus 1. And you're trying to ask, is 0 less than negative 5? Is it less than negative 5? No, not at all. This is false. If that test value comes out with a false statement, then you do not shade on top of that point. That's why we're on the other side. The question number 3 wants us to graph that inequality for y is greater than 6. And y is the only variable in here, so this is going to make us think about our Hoy statement, special cases. So you're going to have a horizontal line since y is the only variable in here. So at 6, 1, 2, 3, 4, 5, 6, there we are. We're going to have to graph that horizontal line and determine, based on the inequality, is it solid or is it dotted? That is going to be a dashed line. We have only a greater than, no underline for the equals, so it is just a dashed line for us. And then thinking about the shading, y is greater than, shade those values that are going to be above the line, which is here. Again, if you like to use those test values and you like to use that 0, 0, by all means. So if I want to test it out with 0, 0, so my y value gets replaced with the 0, and I'm asking, is that greater than 6? Could 0 be greater than 6? No, not at all. 0 is not going to be greater than 6. That's false. So I do not shade on top of this. I go to the other side of my line to shade. So as we move along to number 4, we're going to write our own inequality. Recall that we want this to be in that format of y equals mx plus b. So we need to identify what the y-intercept is on that graph. We can see that this is happening 1 unit above the origin, so my b value will need to be a plus 1. We need to calculate the slope of this line, up 1, right 1, up 1, right 1, up 1, right 1. So you're looking at a 1 over 1 for the slope. And we need to determine the inequality symbol for this. I can see that my shading is happening above the line, so that's going to clue me in that this is a greater than. I can see that I have a dashed line, so there will not be an underline with that symbol used. Keep that y and keep that x. And if you go ahead and simplify this now, y is greater than x plus 1 because we don't need that invisible coefficient. So that would be our inequality. Now that next item, number 5, wants you to select the graph that represents our y is greater than or equal to 3x plus 1. So in looking at this, I'm going to start by considering that inequality symbol. I see that it has the or equal to underline with it, so I know that means that I need to have a solid line on my graph. Graph number 3 and graph number 4 will not be possible since they are clearly dotted. Also, with that symbol, we have the y is greater than or equal to. That greater than symbol says that we are going to be shading above the line. So which of these remaining graphs has the shading above? That would be our first graph with shading up above the line. The second graph that we have puts the shading down below. So as we continue on and look at graphing for a system of inequalities, we're going to graph each of these one line at a time. So y is greater than or equal to a 1/2 x plus 3. I begin with my y-intercept, plotting that at 3 on the y-axis. Count out my slope, where slope here is a negative 1/2. So we are going down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. And I'll also turn that around, up 1, left 2, up 1, left 2, up 1, left 2. Decide if this is going to be a solid or a dotted line. We have the extra underline for the or equal to, so that solid line tells me that we have a solid line on our graph. And decide on your shading. Right now, y is greater than this expression, so the shading would have to be up above, so I'm going to put teeth up above to remind myself of that. go ahead and shade the second item here. Y is less than a 2x plus 4. Begin that with my 4 on the y-axis. 1, 2, 3, 4. And then 2x uses my slope as a 2 over 1. So we'll be going up 2 and right 1, up 2, right 1, up 2, right 1. And I'll turn that around as well. Down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1, down 2, left 1. So that we can create this line. Look at your inequality symbol to determine if this is going to be a solid or a dotted line. I do not have any equal to option. I do not have any inclusion. So this is going to be dotted or dashed on your graph. And consider that shading. Right now it reads that y is less than this information. So less than says that we are going to be shading lower. I'll put some teeth on the lower side of my line. Now your solution is that area where you will have the overlap of those two teeth. And so where you're going to find it is here. My teeth point at each other. They are going to be interacting with each other in that zone towards the upper right. Now when we go ahead down the page to the number 7, again, graphing two inequalities for us. And so my first one will be this y is less than or equal to 3 halves x minus 5. So I'll begin with that negative 5 on the y-axis, 1, 2, 3, 4, 5 for the y-intercept, and count out my slope there. It's a 3 over 2, so up 3 and right 2, up 3, right 2, up 3, right 2, up 3, right 2, and up 3, right 2. And I can also turn that around, down 3, left 2 to fill that in. Determine if this is solid or dotted for us. We have the extra underline, so this is a solid line on the graph. Then also I know that this is y is less than or equal to. That less than symbol says we would be shading the lower part, so I'm going to put little teeth on there to remind myself. Then when I go ahead and consider that other equation, notice that it's not in y equals format, but I do need to isolate that y variable. So we'll subtract the 4x from both sides. So 2y now is greater than 6 minus 4x. Divide both sides by my 2 coefficient. We are dividing by positive 2, so my inequality symbol stays the same. Y is greater than, and we go ahead and split that up. The 6 divided by the 2 leaves me with a 3. And the negative 4x divided by the 2 gives us a negative 2x. Use that to plot our second line now. 3 on my y-axis for the y-intercept, right? You might be used to y equals mx plus b. In this case, we've just written it as a y equals b plus mx. So my b value is still that 3. That's the constant. Slope is a negative 2. I'm going to count it as a negative 2 over 1. So down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. And I can turn that around, up 2, left 1, up 2, left 1, up 2, left 1. Determine if this line will be solid or dotted, and here we can see that it is a strictly greater than symbol, so that will be dashed or dotted on your graph. You cannot make that a solid and continuous line since you do not have the or equal to. And when I read it, y is greater than, anytime y is greater than, we're going to be shading above the line, so I'll put some teeth on to note above. Determine your shading area now. Where do the teeth overlap? Where will the teeth chomp, chomp, chomp? And that ends up being in this section of our graph. So on number 8, with the x plus y is less than 1, I want to make sure that we have this solved for y. So to get that y alone, I need to subtract the x from both sides. So y is less than 1 minus x. Again, this one comes out, instead of y equals mx plus b, y equals b plus mx for us to work with. So the b value, the constant as my y-intercept, is at 1. And my slope there is the negative 1. You're counting that as a negative 1 over 1. So for the invisible coefficient, down 1, right 1, down 1, right 1, down 1, right 1. And you can turn it around, up one, left one, up one, left one, up one, left one, up one, left one, to continue on that graph. Determine if this is a solid or a dotted line. We are going to have a dashed line or a dotted line here. This is strictly less than, no inclusion, no equals to. And so you might put some dashes on your graph, or there are enough dots here that maybe you are just going to leave it as such. Determine your shading. Y is less than, and so less than means that we're going to be shading lower. So I'll put some little teeth on there to remind us. Go ahead and graph that second line then. Y is greater than or equal to 2. Special case again, only one variable shows up. You got to be thinking, hoy, Y is the only variable. So we're going to do that H for a horizontal line at 2. Find your 2 on the y-axis, prepare to make your horizontal line. Just decide if this is going to be solid versus dotted. And we see on that inequality symbol the extra underline for equals to, so that's going to make the solid line on the graph. And y is greater than this, so mark off the greater than areas that are up above the line. Go ahead then, and we get to shade the overlap. Here's our overlap zone. Now, as you move into number 9 and we're asked to select the coordinates that are going to satisfy that system of inequalities, you might find yourself that drawing the graph for these two equations is helpful, or perhaps you could also put them into your graphing calculator. So my 3x plus y is greater than or equal to -3 from the top equation. And then my x plus 2y is less than or equal to 4 from the bottom equation. And so we can see where that comes up. Now recall that the solution is where both of my shadings overlap, as well as any solid border points around that shading. So for my first point that I will try out, I'm going to look at the ordered pair of 0, 0. And I can see that that point's coming up in green. Does this point end up within the area where my shadings overlap? Yes, it does. I can see the blue, I can see the red. This green point ends up in my purple area. So certainly then, yes, this is a solution we can use. Try my next point, looking at the ordered pair of 3, 1. This point is in the red only area. It has to be in the overlap, so that is not going to work for us. I'll look at my next point. We're talking about the ordered pair at 0, 3. And when I plot that, 0, 3 is again in the red only area. Does not involve itself, does not get into the overlapping zone. So this would not be a solution. My last ordered pair is at 2, -1. Look at that point. We can see this within the overlapped area. So yes, this is also a solution to the system. The number 10 down below that is asking us to determine which area of the graph should be shaded. So again, I want to look at these two items and consider them. 2x plus y is less than -2. And then also 2x minus 3y will be less than or equal to -6. So here we are with our graph, and you can look and identify based on the coloring which area has the overlapped shading. We can see that happening towards the left side of our picture, so that would indicate to us that we want this region number 4 to be the one that gets shaded. Now, lastly, at the bottom of our page, we want to write the inequalities that create this graph we're shown here. So I'm going to go ahead and begin with this blue line that we have. Certainly, you're welcome to start with the red, whichever one really strikes you. When I look at that blue line, I see that it is a horizontal line, so I start thinking hoy, and I know y is the only variable that I want to show up. I can see that my blue shading is happening up above my blue line, so I know I'm going to need some kind of a greater than symbol. And this is a solid blue line, so that means I need that solid underline with it. What value is this horizontal happening at? This is occurring at 4. So there's my first inequality. The second inequality, I'm going to base off of my red line. Again, there's nothing wrong if your inequality 1 is my inequality 2 and vice versa if they got swapped. So for inequality 2, think in y equals mx plus b format, I have a y-intercept at 5. So that's where I will begin. I need to know what the slope of my line is, and I can see that we go up 1 and right 1 to get back to another point. So let's see, 1 over 1 is the coefficient that we have on x. And I have to pick my inequality symbol then to get filled in instead of that y equals mx plus b, right? Is it y less than or y greater than or anything? And so I can see that the shading is happening below that line. So that tells me it's a less than. Now, is it less than or equal to, or is it just less than? We have a dashed line or a dotted line, so straight old less than. And if you simplify that, y is less than x plus 5 because that 1 over 1 can be our invisible coefficient. So here are the two inequalities that we would use to create that graph. I hope you're feeling so much more confident now about all things dealing with linear inequalities and systems of inequalities. Have a fabulous day.